Happy Thursday and welcome to today's episode of Tech Bites. This is two streams in a row and I'm back in my office in Central Ohio. I was in Northern Ohio yesterday, Northeast Ohio, and I want to know where you're from. We are live on four different streams. We're live on LinkedIn, YouTube, the social media formerly known as Twitter and Facebook. I think that's all four of them. But let us know where you're from. We've got Felicia and Jeffrey relaying that. We've got a great topic here today. Let's roll in our guest today. I'd like to introduce everyone to Ken Kramer, CTO, Data Center Strategy of Involta. Really good service provider, a lot of Ohio ties here in Involta in Ohio as well. I love me some Ohio stuff. But Ken, you want to do a quick intro?
Yeah, thanks, Rick. Very happy to be here. Thanks for having me on your podcast here. Love Ohio too. We have many locations in Ohio we do business out of. For me personally, I'm the CTO of Data Center Strategies for Involta. Been working on data center builds and operations for 25 plus years. So I'm excited to have a conversation about what's going on in the industry.
Yeah, and so Ken, you're based. It's funny. It's like, well, a split time between Iowa and Florida. In Florida currently, sometimes in Arizona. I know how it goes. Try catching up with me. So, big
Yeah.
welcome and thank you for the partnership there in Involta. In fact, just yesterday I was in Independence, Ohio, which is where one of the newer data centers are located, if I'm correct.
Yes, that is correct.
That's awesome.
That's actually, yeah, actually, you know what? We'll talk about this over time here, but that's one of our latest generations. So we internally look at our generations 0 or 1 through 6. We're working on prototype 6. So that's one of our latest and greatest. So hopefully you
That
had a chance to stop by.
No, I didn't. I had such a
Ah,
wicked, crazy schedule. I didn't stay the night or anything. It was just up and back in the same day. But I will definitely, we will get into that because I
yeah.
think what a mature service provider does really can translate to some great advice. So let's go over to the slides here. And that's really what we're going to talk about here today. We're going to talk about data center density and PUE advice. And if you don't know what PUEs are, stand by. But I do want you to know what type of problem we're trying to solve. And this does kind of sit into uh, the meme joke world of horrible things that can be done in IT. And if you're an individual end user, if you worked with different types of customers, if you've like been on the solution side, people have seen data centers like this. And I'm going to just make an assumption, Ken, this is absolutely not acceptable in your practice.
No. Uh, it makes me cringe.
Yeah, exactly. So that's the problem. We're going to go the complete opposite here. But as we talk about those generations, I think we'll get into it a little bit more. But I just came up with temperature, power, serviceability. Those types of things are important when you build a data center. But from your practice, is there more to this? Is there something missing or anything you'd want to add?
You know what? I think across all of those is really your uptime. That's what everybody's there to achieve is uptime on in their data centers. Obviously, their workloads are becoming more and more critical. So, staying within the SLAs that you put out to our clients as far as temperature, power, do all the maintenance, and that's the serviceability. It all comes around with what they expect to be delivered, and that's uptime, right? So,
I am with you there on uptime, and that's yeah, I'd say that's kind of like an overarching theme. And when I talk to a lot of people who consume service provider or hosted infrastructure type of services, it really comes down to that is a better offering than what we can do on our own. And I will be the first to admit, here at Veeam, we hold a part of our critical infrastructure in a hosted environment because in this building the power goes out a lot, and so the uptime becomes a high risk. So totally agree. So I guess I'll just start. We mentioned these generations, and this is really one of those big questions when it comes to building a data center. I think we have a slide on the generations here, but what really drives you in your practice and your extended teams to make these new generations? I got to think some sort of like efficiency and economics come into play, but what are some of those features that help you drive that?
Yeah, no, that's a great question. I think over the years, you're always chasing, and we'll get into a little bit of this, but that density. So as data grows, so does compute power. More compute power is more heat. More heat is the definition of density in these racks. Just the growth of data and how it's being used is substantial, and it's not going to go away, right? So as you start taking a look at generations, and every company has this same approach, but you got to make them more dense. You have to have different cooling strategies. You have to have more delivery to the rack. So all of those are tweaks that you make within the design, and you hit on it. You got to do that with keeping economics in mind, as well as being more and more efficient every time you build a new one and you operate them. So a lot of moving parts inside the thought process that goes into a new design, and you got to take those all in consideration.
I guess another one we have to think about, Ken, really would be latency. So I like to, this is an area very far out of my area of expertise, but well, if temperature is an issue, why don't we like pull in some ambient cooling, like put it up in the Arctic, right? But then we have latency challenges to the people subscribing it. So I'd actually add that's door number three of consideration.
Yeah, and latency, whether you like it or not, is really driven by location. So
Yeah.
latency to what, right? So one of the strategies we had is to go more into secondary markets that are typically underserved, specifically for those latency and provide some I'd say, services in these tier two markets that traditionally people have kind of not focused on. So I think that's why we've been pretty successful in the Northern Ohio area, when we came into that market. So latency, you can't change the speed of light, right? So latency has all got distance in there. Certainly with folks going to more hyperscalers and cloud services, they need that latency consideration too, as it really becomes a hybrid environment that we're trying to solve for.
Yeah, so a couple of points. I don't know if you know this about me, Ken, but I used to work in the supply chain automation space,
Oh,
and
sure.
there's a very, very like interesting angle, and that's why one of the large parcel freight operators have a mega hub in in Memphis. The other one has a mega hub in Louisville, and then the big online retailer that starts with an A has a big transport hub in Cincinnati. That Ohio Valley is a very interesting logistics hub
Mm,
that I forget the exact statistic, but within a day's truck drive, you can reach a very significant portion of the U.S. population, which would include, New York and Chicago
sure.
and the mid South. And so, in a way, you could almost equate a truck drive to like 5 milliseconds of latency when it comes to the internet and stuff. So
Hmm.
it's really interesting when I see my two disciplines kind of collide from 20 years ago
Yeah.
when I worked in the supply chain. Producers just let me know that the map is up. So let's take a look at the map location. We need some US states, friends. Let us know. I'm going to add Arizona because one of our producers is on as well, kind of on the shadow side. Portia from Arizona. So let's add that. Oh, real time. Look at that. Like almost professional. I love it. We've also got Dominican Republic in the Caribbean. Welcome. I think your weather is better than mine today. Let's go over to Europe. We got Brazil. Sorry, that's not Brazil. That's Spain and Portugal. Right language, wrong continent. Welcome European visitors. And then we also have Madagascar and Oman. Madagascar might be a first for me in my live streams. But, anyways, let us know where you are tuning in from. We will light the map location up. So I want to talk now about a little bit of your practice, Ken. And again, I really love the innovation and the really advanced solutions that a lot of our service provider partners bring. But let's walk me through this like power density chart here, because this is like I think a lot of people can learn here from this.
Yeah, absolutely. This chart really resonates with me and what our journey has been, over the years, dating back in the early 2000s. Our first data centers, we were building to accommodate a lot of the enterprise data centers that wanted to transition into colo space, get rid of the day-to-day maintenance on that, avoid some capex. Anyhow, we were at that 3 to 5 kW design and accommodating. I think up until just a few years ago, we were still under 3 kW from a overall density average across all racks in service, all 10 megawatt racks and or 10 megawatt facilities. And as we see, the growth pattern on densities has really taken off. I think, there's studies out there you can go look at, but the rate by which IT and technology as a whole is developing is exponentially, and who knows where it stops. So this is kind of when we take a look at density, one of the biggest challenges, you can pack in power as tight as you want, but you got to cool it. And that's where the some of the innovation starts to come in. And I thought this was kind of a neat little graph here that I've used several times to kind of show the different thresholds where you have to start going to different cooling technologies as the densities continue to rise. And there's racks out there, single racks, 24 or 30 inches wide, 6 feet tall, that are pumping 200 kilowatts in there. That's a lot, considering, if you don't know what that is, comparable, a house might utilize 3 kW,
Well, my house is
maybe up to
5, I
five.
know. Yeah, because
Yeah,
I have
yeah.
to run my generator sometimes when the power goes out, and I have
Yeah.
a 5 kW, and I can't do the air conditioner. I would need 10. So
Oh,
yeah,
is that
put it,
right? Okay.
well, I have two air cons, so a big house, but
Yeah.
so 10
So.
kW with air con.
Mhm.
So
So once you start getting up into the 15 and higher, you start getting some challenges that you have to start to look at overcoming, and a lot of those are through rear door placements. Nobody likes water in their data center, but water is the best transport of heat, out of a data center. So you come up with some really interesting technologies that I'm sure a lot of folks have heard of before, but you start getting into liquid cooling solutions that you have to bring in here to really transfer the heat away from those hot CPUs, GPUs that are running in your racks. We refer to them as HPC environments, anything that's starting to get above 20 kW. It's really high performance compute. And that can grow to, very large numbers. And there's all sorts of new technologies coming out of there. They continue to evolve. We'll talk a little bit about some of the energy efficiencies and what that means to us going forward. But really, it's how do you keep chasing the densities and serving the customers? Because, like I said before, the data's not going anywhere. It continues to grow, and you gotta do something with it. So you continue to put more and more compute, you analyze the data, um, and that's really what's driving a lot of this heat.
yeah, a lot to unpack here. So a couple
Mhm,
acronyms: crack, computer room air conditioner.
mhm.
AHU, what's that? Auxiliary heat unit or
Air handling unit,
air handling unit? Okay.
yeah,
Yeah.
yeah,
Cool. And then one thing I'll add is I guess I started my IT practice kind of in the second bar here, perimeter, crack, raised floor, containment. That's how I work.
mhm,
And then a couple of different data centers over time started getting into passive and active doors. One thing I'll tell you, I had a chance to visit Storage Review, which is storagereview.com, one of the analyst media evaluation type firms, and they have one of those GPU systems with liquid cooling in the box.
yeah.
That blew my mind, Ken. Again, I don't know if it's actually water. It might be like a antifreeze.
It's like a glycol.
Yeah,
Yeah.
glycol situation. So,
Mhm.
whoa, it's getting complicated. High power, high heat, high risk with, I mean, I'm like, how I was freaking out of water in the motherboard,
Yeah.
when I saw that. And I was just like, whoa. But let's
Yeah.
talk a little bit more about this direct cooling. This looks like, is this an implementation at one of your Gen 5 facilities?
Yeah, it is. And I'll just comment one thing. I was kind of wowed the other day. I was talking to someone, they're like, yeah, I bought a new desktop computer and it's liquid cooled. And I'm like, what? So, I mean, obviously they're coming out with a lot of different designs, even out to the consumer, the home user, those types of things, because, they're all running faster, they're all creating more heat, and they've just some innovative solutions. But we've got a little bit of history and experience putting in some direct liquid cooling, and it becomes complicated when you start, to your point, bring water in the data center. So we've worked years to keep water out of the data center, and here we are piping water in the data center. So there's all sorts of challenges that start to come with that, right? So what if you have a leak? How are you going to contain it? How are you going to do these heat exchangers? What kind of power do you need from a distribution to do that? So this is just a couple pictures and drawings that it's not a simple deployment. Like
Mm.
I'll go back to where you can order a direct or a liquid cool processor, for your home computer, and it's all packaged and it's an easy thing. You start looking at these really high densities and these new designs and that has efficiencies that are really a directive. It's a complicated process, especially when you try to work in redundancies in the CDUs out on the floor, on the back end heat exchanger, on the chillers, the pumps. I mean, if that stops, you're basically either going to slow all your systems down to a very reduced rate so they don't like overheat, right? Um, or you're going to cause damage. So that kind of goes back to that always up, always available, SLA driven operations. And this just becomes another complicated part of that whole ecosystem. So this one specifically, we did some calculations, and the net result of our installation of the direct liquid cooling, we got 50% more compute capabilities. I mean, you can read it here, but in 25% less space. And one of the things we'll talk about, and even more important, is reduce the power consumption overall for it. And a lot of that was around our PUE that we'll talk about a little bit. But we're able to get more efficient, pack more power, pack more horsepower in their compute systems in a smaller footprint. So that's really what's driving it.
So on the 10% power reduction, I want to make
Mhm.
a guess here. Is that because device cooling systems like fans are revving less? Is that kind of
That's correct.
one component of that? And then the
Yep, yep.
other element I'm looking at, and I'm no engineer, but this thing right here that exists in the redundancy, is this like a limit switch that would, if flow goes too fast, it shuts it down? Like there might be a problem, because it's like there's an expected flow, but if it's going too fast, there might be a leak or something like that. Is there logic like that on this type of
Yeah.
system?
There's valves that shut off if it detects overflow. There's expansion
Hmm.
tanks that are included within the piping, because as water heats up and cools down,
Yeah.
um, in this case, there's a glycol on the outside, and there's heat exchangers on the inside to what we call clean water that goes out to the CDU that feeds the actual server. So there's different series of heat exchangers in line, and they all have to be redundant, right? They
Mhm.
all have to be able to handle the load. So a lot of controls that have to lay on top of this to really get it to act or to function properly as well.
Wicked, wicked. I love this stuff,
Yeah.
Ken. Again, love the innovation that Involta's bringing, just this extra. This is a very different type of show for those watching, and a couple comments have come in that this is great. great content, and so it leads me to my next content here is or question here is like, what does this design look like and how is it measured? And I think that we talked about in the title and earlier just a second ago that there's this notion of PUE and it's a math formula here. And Ken, is this something that you and your colleagues use every day and part of the design, or is this just vaporware?
No, it's really what's it's looked at across the industry, and it's one metric that is tracked to see, number one, how well or how efficient are you operating your facilities. Um, and if for folks that not quite sure what it means, if you're using a 1 kW to serve a server and it takes another kW to cool it, you're at 1.5. So you're trying to get that number down as close as to one as possible. That means you're not using any energy to cool or to maintain that environment. Um, so uh, we work every day to try and do things to invest into energy efficient equipment, to do containment, whether it's cold aisle, hot aisle containment. How do you best drive down that energy usage? Everybody knows that data centers have a big target on their back because they're a big energy user, and we'll touch on here in a little bit ESG, but um, the world is getting more and more aware of energy usage and how it's produced and what the greenhouse gas emissions are. And it really takes a focus when, you look at some of these hyperscalers and these large data center companies building 130 megawatt campuses or even more. I just heard and seen on some news feeds that they're planning a gigawatt data center. And it's just like, where's the end? Where does it stop, right? So it's an important calculation. I think it's an industry standard everybody keeps track of.
And I think whether you're big or small, I think this is a good conversation starter. There's the power that you spec to the device, but then there's the power for cooling, and you could also, I guess, include lighting and things like
That's right.
that. So everybody could really benefit from these calculations. And I've been there, Ken. I remember in one of the roles I had, we were like sizing the facility generator. Okay. Now, granted, we hired electricians and professionals about that, but that was right at the time when we were consolidating from a, a truckload of physical servers to virtual. Our power went down, which was good, but we were just really in a sizing drill. And it becomes important when you think about the generator for a resiliency standpoint, the batteries in the room before the generator kicks on, all of those different things. And, for our audience who have been through some of these data center type tours, these things matter. And it really comes down to it's next level sizing, kind of beyond your gigabytes of RAM and terabytes, petabytes of storage on scale. This stuff matters, and the sustainability. You mentioned that
Mhm.
reporting trackable target. Tell me a little bit about how you and your staff look at that from a environmental sustainability growth type of perspective.
Yeah, Rick, we could talk for hours on this.
It's a
And
30-minute show, Ken. Come on.
yeah, I know it. And you could get political whether you're a big believer in global warming and things, but uh, nonetheless, it's out there. We all have to be accountable for the greenhouse gases that are being emitted into the atmosphere, right? So we have started focus on actually from day one. Our first data center, there wasn't a lot of these programs, and we looked at complying with LEED. So it was energy efficiency. This was back in the early 2000s, right? It didn't really line up. It was the only thing we could grasp to say, hey, we're doing the things, we're spending the money to really reduce power consumptions and be energy efficient. Well, this has evolved over time, obviously, into ESG. ESG, if you're not familiar with it out there, I'm sure you heard of it. Everybody has. We're ingrained in it. It's something that's driving a lot of our decisions and our day-to-day decisions on how we invest dollars in energy efficiencies. We just released our 2003 report. We've gained ground. We have a goal of getting 100% carbon-free operations by 2030. It's an aggressive goal, but we also line up with our customers, right? If you know anything about the ESG and the calculations, there's scope one, two, and three. We're a scope three for our clients, and they're expecting us to do our share in reducing and meeting their goals. So one of the ways, and it's kind of highlighted here, but um, you know, one way to track it is, are we making progress on our PUE calculations or our PUE results? And last year I think we gained 18% improvement. It sounds like a small number, but every piece counts, right? So we'll continue to eat away at that. We'll continue to search for clean power, renewable energy, and do our part where we need to and serve our customers.
So a couple of things to unpack here, Ken.
Mhm.
I'm going to do it for you, but I think a lot of our audience is not able to spec, design, build their data center footprints to this level of PUE and and ESG, those level one, two, threes that you just described. And if
Mhm.
you're out there and if your management is focused on these types of topics as well as, do I need to go buy another data center? I highly recommend that you think about investing your footprint in a offered service like what Involta has. And if you don't mind, Ken, just I know Veeam partner, a service provider, but this is also so much more. Just a couple of things. What kind of services does Involta offer?
Yeah, well, thank you for that softball.
Yeah.
Uh, what we're focused on is bringing high efficiency, cost effective data centers to the markets. Additional to that, we do have a cloud environment. We believe there's options other than the hyperscalers. So we have a cloud. We do backup services. We use Veeam extensively. We have some DR services. So what we're really trying to do is be a piece of that hybrid IT infrastructure that people are utilizing, and that's really what we're after. So
Yeah, love it. And like I said, Veeam partner, very established, lots of Ohio roots. I like that. So that's good stuff. Producers have let me know the map is ready one more time. Let's take a final look. We've added Idaho. Welcome. That's a new one for me. Lit up Arizona for Porsche. And then let's see who else is new. Down in South America, we have Brazil. Always good. Hey, Beth, thanks for watching. We saw you on the chat. And then we've also added Pakistan. It's kind of late, but I would stay up for this. This is a good show, everyone. Awesome. So thank you all for joining and letting us know where you are from. So, Ken, any kind of closing thoughts here? I mean, this is just fantastic information.
my closing it really would be around, you got to pay attention to this, pick a partner that has a focus on energy efficiencies and really understand what your IT needs are. We're here to help. Um, Give us a call if you have a need.
Yeah, indeed. Or go to Involta.com. Our Veeam team is also very well versed in Involta and their offerings as well. Thank you so much for being with us today, Ken.
Absolutely. Thanks for having me.
Oh, my pleasure. I love it when I learn stuff. This is good stuff. So, a couple of promos. I have to write this down. Tuesday, the 14th, next week, Industry Insights is up with Jason Buffington and Leah Troskineski talking about the cloud protection trends 2024. Woo. Kickoff about backup as a service and DRAS as a service, which is one of the services that you can get from Involta, by the way. And then on the Tech Bites on the 16th, Smart Storage Made Easy. Kirsten Stoner is hosting Hitachi Vantara to talk about some of the advanced unified storages. And guess what? VMon, that's coming up next month, and I'm way behind in everything I need to do. You can still register for 10% off with the Ricketron 10 code. All right. And on behalf of Jeffrey and Felicia, our producers, I could not do that without them. Big thank you to both of them. Thank you, everyone, for watching, and that concludes our stream.